Okay, so where do we leave off? We were just talking about how if we find the second derivative, it can give us information about the concavity. And concavity is important because if we know the concavity, then a tangent line or linear approximation would be an underestimate if we had a concave up graph, and if we had a concave down graph, we would have an overestimate because that tangent line or linear approximation would be above. So specifically talking about this point, this f of negative 0.4, if we think about that location on the axes, we'd have f of negative 0.4 was approximately equal to 1.52. That puts it over here in quadrant 2. In quadrant 2, our x values are less than 0, but our y values are greater than 0. If we plug in those values into our second derivative right here, a negative value for x would result in a positive number, which would mean in quadrant 2, the second derivative would always be greater than 0. Therefore, our estimate has to be an underestimate because our function is concave up. So we would say, therefore, 1.52 is less than the actual function value at f of negative 0.4 because f of x is concave up in quadrant 2.